In the section of optics, there's a phenomenon called total internal reflection, which is a phenomenon that occurs when the angle of incidence is greater than the critical angle for a certain material. So in order to calculate the angles for which total internal reflection occurs, we first need to be able to calculate the critical angle for a substance. So critical angle is the angle for which, or the angle of incidence for which the angle of refraction is 90 degrees. So as we can see here, the ray of light has to be traveling from a more optically dense medium, in this case diamond, to a less optically dense medium, in this case air. And as we can see, the critical angle is the angle for which the angle of refraction is 90 degrees. And we can calculate the value of that angle by using Snell's law, which says that the refractive index of the first medium multiplied by the incident angle is equal to the refractive index of the second medium, in this case air, multiplied by the refracted angle. We can then substitute the values that we have. The refractive index of diamond is 2.42. Sine of the incident angle, which is also called the critical angle, theta c. The refractive index for air is 1, and by definition of critical angle, the refracted angle must be 90 degrees. We can then rearrange this to show that sine of the critical angle is equal to sine of 90 divided by 2.42. And we can then rewrite that and type it into our calculators as second function sine of 90 divided by 2.42, which means that the critical angle for diamond into air is 24.41 degrees. What that means is that total internal reflection will happen for any angle of incidence greater than 24.41 degrees, and for any angle less than that, you would have normal refraction of light.